Hello, everybody. Welcome back. In the last lesson that you did, we talked about variables, right? And we said that a variable is anything in an experiment that can change or be changed. So, for example, if you were looking at how well someone does on a test, right? What are some variables that could affect how well someone does on a test? Well, whether or not they got enough sleep the night before, right? That could affect how well they do. Whether or not they had breakfast, that could affect how well they do. Whether or not they studied. Those are all things that can change that could affect the results of the experiment, that could affect how well the person does on the test. So today we're going to talk about types of variables because every experiment should have several different types of variables, and it's really important that you understand what those are so that you can design a good experiment yourself. Okay, so looking at this picture right here, we are going to use a growing plant as our example for this set of notes. So right now you should be open to slide 14 and 15 in your inquiry unit INB, and you should be adding notes as we go through this video to your INB, and then doing the processing activities as we go, highlighting keywords and writing some things in the margins of your notes, and I'll tell you when to do that. Okay? All right. So the essential question for this set of notes is, what types of variables should a good experimental design include? Okay, what types of variables should a good experimental design include? Okay, every true experiment should include the following variables. Okay, so one variable that every good experiment should include is the independent variable. And that's a really big word, so sometimes we just call it the IV. Okay, the IV is the thing that you change on purpose in an experiment. It's the thing that you're testing, okay? The thing that you are testing. If you want to add that to your notes, you can, okay? So for example, in this picture down here, right, we have 4 plants set up, and we want to know how the amount of fertilizer, okay? So you can see that little green drop down there, little green drop, that represents fertilizer, okay? And fertilizer is just a nutrient that you can give your plants to help them grow. It's supposed to be healthy for the plant. So we want to know how the amount of fertilizer that you give a plant, we want to know how that affects the growth of the plant, right? We want to see if it helps the plant. So we're going to have one plant over here that gets no fertilizer at all, right? No green drops. The second plant is going to get 2 green drops. The third plant is going to get 4 drops of fertilizer, and then this last plant will get, looks like 6 drops of fertilizer, okay? So in this case, the independent variable, the thing that we're testing, the thing that we're changing on purpose, is the amount of fertilizer, okay? All right. All good experiments should also have what's called the dependent variable. And often we will refer to this as the DV because it's kind of annoying to write out dependent variable every time you want to say dependent variable. So if you just want to call it the DV, that's fine. The dependent variable is the result or the outcome of your experiment. It's the thing that you measure at the end of the experiment, okay? So for example, in this case, right, we're changing the amount of fertilizer that each of these plants gets. And at the end, in order to see whether or not the fertilizer made a difference, we're going to measure the height of the plant, okay? We're going to see how tall the plant got and see if plants with more fertilizer grew taller. So in this case, the result or the outcome of the experiment, the thing we're measuring at the end, is the height of the plant. That would be our dependent variable. Okay. At this point, what I would like you to do is I want you to stop, okay? Take a look at your notes on slide 14 in your inquiry unit INB, and I would like you to do this processing activity. In the left-hand column of your notes, so over in the little left-hand column, right, we're doing Cornell notes. So over in the left-hand column, explain the difference between an independent variable and a dependent variable. Explain the difference between an independent variable and a dependent variable. Try to put it in your own words. So go ahead and pause the video and add that to the left-hand column of your notes. Okay. Designing an experiment with variables. Okay, so we've talked about independent variables, we've talked about dependent variables. Now I want to talk a little bit about constant variables, and oftentimes we will just call them constants, okay? Constants are all of the variables that must stay the same, I'm going to underline that, same, between groups, so that you can measure the effects of the independent variable, right? You can't see whether or not the thing you're testing makes a difference unless you keep everything else about your experiment the same for all of your groups, okay? So your constants should be all other variables except the one variable that you're purposely changing that could affect your results. Okay, so I'm going to say that one more time because that's really important. Constants are all other variables except for the one variable you are purposely changing that could affect your results. All right. So for example, if we look at our 4 plants down here, right, we want to know whether or not the amount of fertilizer, so the number of green drops, affects how tall the plant grows, right? So in this case, the only thing that should be different for each plant is the number of green drops, right? The amount of fertilizer. Everything else needs to stay the same, right? Otherwise, this last plant, the one that got the most fertilizer, we wouldn't know whether it grew taller because it got more fertilizer or whether it grew taller because it got more water, right? We wouldn't know that it was the fertilizer that was causing it to grow taller unless we keep everything else, like the amount of sun that the plant gets and the amount of water that the plant gets, the type of plant that we're using. All of these things need to stay the same. Otherwise, we don't know that it's really the fertilizer that's making the plant grow taller. Okay? So in this experiment, there would be other constants too. You could come up with a long list of constants, but some things that we would need to keep constant in this experiment are the amount of water that the plant gets, the amount of sun, the type of plant that you're using, right? These are all variables that could affect the height of the plant, and we want to keep those constant. We want those to be constant variables because the only thing we want to change between our 4 groups of plants is the number of drops of green fertilizer. Okay? All right. Sometimes an experiment will have one or more control groups. Okay? The control group, you can sometimes call it, I'll circle it, you can sometimes call it the CG, the control group, is the group in an experiment that does not receive treatment, okay? You can think of it as the comparison group, okay? Sometimes there's more than one control group in an experiment, okay? Sometimes you have an experiment where sometimes there may be no control group. Sometimes there may be 2 or 3 control groups. A lot of times there's just one comparison group, one control group. But it's usually the group that gets no treatment. So, for example, in this situation, right, with our plants, we have our first plant is getting no drops of fertilizer, 0 drops. This one is getting 2 drops. This one is getting 4 green drops. And this one is getting 6 green drops of fertilizer, right? So in this case, our control group would be the plant with 0 drops of fertilizer, okay? This one right here would be our no treatment group. And we can use it as a comparison group, right? We want to have this plant because we want to see if the fertilizer makes a difference at all, right? Here we're giving plants different amounts of fertilizer to see if the amount makes a difference, but we need to compare that to a plant that gets no fertilizer because maybe the fertilizer doesn't even make a difference. Maybe it doesn't matter how much fertilizer the plant gets. Maybe it didn't need any fertilizer in the first place, right? Maybe it would have grown just fine without the fertilizer. So we need this comparison group. We need this group that gets this plant that gets no treatment to be able to make a claim about whether or not the fertilizer really has an effect. Okay, so just a couple of important notes I want to mention. Okay, a fair test has only one independent variable. Okay, only one independent variable. You should have only one thing that you are testing and changing in your experiment. All other variables that might affect your results need to be constant. They need to be kept the same for all of the groups in your experiment. If you do this, then you can be confident that your results are because of the independent variable, right? So in this case, the number of drops of fertilizer, that's our independent variable. And if we want to be confident that the height of the plant is really caused by the amount of fertilizer that the plant got, then we need to make sure that the amount of fertilizer was the only thing that was different for each of our 4 plants. Otherwise, we can't say that the fertilizer is really causing the plant to get taller, okay? Unless we keep everything else the same. Everything else, like the amount of sun and the amount of water, all those things have to stay constant, okay? Now, just a quick note, there might be some things that that don't have to stay constant, right? So the only things that you need to keep constant in your experiment are the things that could affect the results, right? So do you think that it matters what color pot these plants are planted in? Probably not. That's probably not something you need to keep constant, right? It's not going to affect your results. Does it matter who waters the plants every day as long as they are watering them the same amount and doing the exact same procedure? Probably not, right? So just think about, when you're thinking about your constants, make sure you're thinking of variables that could really affect the results, okay? Because not all variables are going to affect your results. Okay. So here's your processing activity. I'd like you to go ahead. Oops, there we go. I'd like you to go ahead and stop the power or this video. Just pause it for a second, and I would like you to go back to your notes on slide 14 in your inquiry unit INB, and I would like you to highlight important vocabulary words in the notes so far. Up in the top toolbar, there's a little button that you can click that will allow you to highlight words in the text. So if you click on that little button and then go through your notes and highlight important vocabulary words, okay? Then your second processing activity, your second task, in the left-hand column of your notes, so over on the left-hand side in the little column, I want you to write one quiz question about either constants or control groups. So in other words, if you were the teacher and you had to write a quiz about this set of notes, what quiz question would you write and give your students about constants and control groups? So write me a quiz question that I could put on one of my tests about constants or control groups. Go ahead and put that in the left-hand column of your notes. Okay, go ahead and pause this, and then you're going to come back for the last little bit of the video. Okay. Let's do a practice problem and see if we can identify the types of variables in the bread mold experiment. So we're going to be doing an experiment with bread, and we're going to be setting up, and we're not going to do it yet, but we will set up the experiment pretty soon here. And you're going to have a loaf of bread, and you're going to have 4 slices of bread here. We'll probably do multiple trials, okay? But you're going to have 4 slices of bread. So in the first baggie, you are going to have, we'll call it number 1, you are going to have a piece of bread that has been untouched, okay? And then in the second baggie, you're going to have a piece of bread that has been handled and touched with unwashed, dirty hands, okay? Your third piece of bread is going to be handled with hands that had been treated with hand sanitizer. So you're going to put hand sanitizer on your hands and then handle the bread and then put it in this bag, okay? And then in this last one, number 4, you're going to wash your hands with soap and water. So no hand sanitizer, soap and water. And then you're going to handle the bread, and then you'll put the bread in the baggie, okay? And then over the course of a couple of weeks, we're going to let them sit. And then we're going to come back and we're going to see how much mold has grown on each of these pieces of bread. Okay. And we can assume, right, that the one that has the most mold probably had the most germs on it that came from your hands, right? So this will be a good way to test, how much mold grows on each piece of bread will be a good way to test whether or not washing your hands really gets rid of germs. Okay. All right. So what I want you to do is I want you to pause this video, and on slide 15 in your Inquiry Unit INB, there's a page that looks just like this on the left-hand side. And I want you to see if you can figure out in this experiment, what is the independent variable? What is the dependent variable? Give me a couple of things that we need to keep constant for all 4 baggies, all 4 pieces of bread, and then tell me which of these 4 pieces of bread is our control group or our control groups if we have more than one. So go ahead and pause this and see if you can figure that out. And then you're going to come back. Okay, so hopefully you paused the video and you thought about it a little bit. Let's check your answers real quick. So the independent variable in this experiment, okay, would be the hand treatment, right? How you treated your hands. Did you not wash them at all? Did you wash them with soap and water, or did you use hand sanitizer? Okay, the way you treated your hands or what you did to them is the independent variable. That's the thing we're changing on purpose in this experiment. The dependent variable, okay, is the thing that we measure at the end of the experiment. And the thing that we're going to measure is the amount of mold that grows on each of these pieces of bread, okay, to see whether or not the way you treated your hands made a difference, okay, whether or not washing your hands really helped get rid of germs, all right? So this is what we would measure. What are some things we need to keep the same? Well, what are some other things that could affect how much mold grows on these pieces of bread? Well, the amount of time that these pieces of bread have been sitting out for, right? The longer the bread's been sitting there, the more mold it's probably going to grow, okay? So how long they're sitting there for. We want to make sure that when we go check how much mold has grown on all 4 pieces of bread, we want to make sure that these 4 pieces of bread have all sat out for the same amount of time. Okay. The type of bread is probably important, right? If you have, homemade bread doesn't have as many preservatives as bread that you would buy at the store. So it could be that bread that you buy at the store doesn't mold as fast as homemade bread. So we need to make sure that we are using the same type of bread for all of our groups. Okay. The temperature can also affect how much mold grows on something, right? The reason we put things in the refrigerator is to help them stay good longer so they don't grow so much mold. So we need to make sure that we're keeping all of these pieces of bread at the same temperature. So these are some things that we need to keep constant, some constant variables to make sure that it's really what we did with our hands that affected how much mold grew, okay? Our control groups here, remember the control group is your comparison group, right? It's the thing that it's the group that's there for comparison, right? It's the group that gets no treatment. It's only there for comparison. So in this case, we have 2 control groups, right? Because our treatment groups, one of our treatment groups is the hands that get treated with hand sanitizer. And the other treatment group is the hands that get treated with soap and water, right? The no treatment group is the unwashed hands, right? Your hands didn't get any treatment. And the untouched bread. In that case, the bread didn't get any hand treatment. So these would be your 2 control groups. And these are just here for comparison, right? If we want to know whether or not hand sanitizer and soap and water make a difference, then we need to compare what happens to these 2 pieces of bread to what happens to bread that is touched with unwashed hands and bread that's just untouched, period, right? So these, in this case, would be our 2 control groups or our 2 comparison groups. So what I want you to do is go ahead and pause this video and I want you to go ahead and copy all of the red text. Go ahead and type in all of the red text into the open spaces on slide 15 in your inquiry unit INB. Okay, there are spaces on slide 15 on the left-hand side for you to type in all of this red text. Go ahead and do that, and then you're going to finish the rest of this Go Formative assignment. All right, I hope that made sense, and we'll talk to you soon. Bye.